Hi, my dear Uncle Jimmy. How are you? My dear, continually chapter 9. Flow in closed conduits under pressure. Part H. Water hammer phenomena. Look, my dear, usually any rapid changing in flow inside a closed conduit under pressure, causing an elastic wave, pressure wave, which travel to both upstream and downstream from the origin point. Consequently, the pressure in conduit behind this progressive wave would be rapidly increased or decreased. This phenomena is commonly known as water hammer. Water pressure waves velocity ranging between 900 up to 1200 meters per second and generally considered equal approximately to 1067 meters per second. The maximum pressure rise HW as a result of instantaneous stopping of flow can be calculated as shown in the enclosed equation. Accordingly, the result problem of occurring a series of water hammers in a pipeline while a flow velocity of 2 meters per second under a pressure head 40 meters and suddenly flow arrested in the pipeline. The pressure head will rise suddenly as is case as shown and clear in front of you. On the other hand, if the flow in a given closed system is gradually reduced only and not completely arrested, the pressure head HW will rise gradually proportional to the change of flow velocity as shown in the enclosed equation. My dear, if the flow velocity in the previous pipeline is gradually reduced from 2 meters per second up to 1.5 meters per second, then the pressure head rise will be mathematical calculation as shown in front of you. Water hammer and effective time in infinite and finite pipeline. My dear, a case of infinite pipeline, if the flow velocity is gradually arrested, the resulting water hammer pressure will be the same as if the flow is suddenly stopped. The difference is that water hammer will occur at gradually arrest on a little time depend on both the gradually arrested time and the distance between arrested point and the another upstream point. Take care, my dear, that water hammer problems become complex at case of an finite length of pipeline because the near pipeline end will enhance the mechanism of wave reflection. The original pressure wave is reversed in direction at the line terminus and travels back to the original point, which becomes a point of terminus inducing a second reflection of the original wave. Thus, a signal pressure wave travels back and forth between the pipeline termini until dependent by friction. Look, my dear, the round trip time of pressure wave is usually termed as the critical period of pipeline, T small, or as N unit, we define such as illustrated in the enclosed equation. Identifications of the symbols in the previous equation. Look, my dear, by yourself, and follow it. It's so clear and easy. Look, my dear, sudden water hammer is induced when the total changing in flow velocity is accomplished in a period equal or less than the critical pipeline period. On the other hand, gradually water hammer is induced when the total changing in flow velocity is accomplished in a period greater than the critical pipeline period. Also, table showing water hammer pressure rise and effective time. Look, my dear, an example on calculation the total time closing for gate, globe, butterfly, and ball valves installed upstream of PVC pipeline, and the solution is clear in front of you. The rest of calculation, the maximum water hammer pressure head rise, critical pipeline period, allowable pressure head, and head rise, pipeline condition, and effective closing time of valve. The final calculation of the total safe time of closing gate, globe, butterfly, and ball valves, respectively. Moreover, calculation of the total safe time of closing different types of valves at infinite lengths of pipeline, which concluded that the adjustable total time of valve closing is directly proportional with the line length. Look, my dear, how to control the water hammer phenomena in irrigation systems. Really, there are many devices which can be used as required for controlling water hammer phenomena, such as adjustment both the opening and the closing time of valves installed in pipe systems to be gradually, not instantaneous, for obtaining a uniform rate of velocity variation during the operation cycle. And additional devices such as controlling the emergency conditions in the normal operation of pumps, imposing by power failure to the pump station by using a positively hydraulic pump controlling valve, using quick pressure relief valve, which open instantly when the pressure in pipelines exceeds the set adjustment point, and using air accumulator valves in the critical places, which be effect on absorbing the energy of pressure wave. Also, an additional devices such as using drop pressure valves, which open faster and releasing water when occurring pressure drop suddenly below normal and time to close after returning the positive wave. And also, you can use vented surge tank. Goodbye, my